Hello again, and welcome back to Operations Management. In this session, we're going to be continuing our discussion on statistical process control and talking about inspection and control charts. The purpose of inspection is so that we can actually monitor what is happening with a process. What we can do is we can take samples of product, or we can take a look at the service that's happening during our process, and then we're going to evaluate that against a series of standards. That's what we're doing with inspection. If you're thinking about levels of quality cost, this would be part of the appraisal cost. Now, inspection can be performed at any point in the process, but it's very important to remember that you can't inspect quality into a product or service. All inspection does is identify whether or not there are errors in your process. We're going to be talking about two different kinds of inspection. One is attribute inspection, and the other one is variables inspection. An attribute inspection is a simple good versus defect. We're going to be looking at the product or the service and identifying whether there are defects in the product or whether the product itself is defective. Now, a variables inspection is a little bit different because not only are we trying to figure out whether there's a problem with the process, we're looking at it on a continuum scale of a dimension. We're going to be looking at the overall length, weight, time, thickness, something that we can actually measure numerically. So those are the two different kinds of inspections that we'll be looking at. Some common control charts when we do inspection for variables are the X bar and the R chart. Now, the X bar tracks the mean of samples, so that will give us our measure of central tendency. The R chart will track the range of the sample, so that will give us a measure of dispersion. So if we're looking at a dimension, we want to see what the average of that dimension is, as well as the range of numbers in that dimension. So that's why the X bar and the R chart are always used together, because the X bar gives you the measure of central tendency, and the R chart gives us a measure of dispersion. For the attribute charts, we're looking at a P chart and a C chart. A P chart can track the percent or fraction defective in a sample. So that'll tell us out of a sample how many or what percent of defective units we actually have. Whereas the C chart just tracks the number or a count of defects in a sample. The big difference between the P chart and the C chart is the C chart allows us to count defects that occur on a product, and there can be more than one defect on a product. So that's the big difference between the P chart and the C chart. So if you're trying to figure out what kind of control chart to use, the first thing you have to identify is, are you measuring variables such as a size or weight or something like that? In which case, you're looking at the variables control charts, in which case we'd be using an X bar and an R chart, always together. But if that's not what we're doing, are we just counting or trying to figure out a percent defective, then we're looking at attribute control charts. So if we're measuring a fraction or a percent defective, we're going to be looking at a P chart. And if we're just counting the total number of defects, then we're going to be looking at a C chart. On our next video, we're going to be taking a look at X bar and R charts and how we can actually develop the control limits for those charts. I'll see you then.